Alright, so we got two more topics to go. Today we're doing more inverses and talking about their domain and range and compositions of inverse functions. And then tomorrow we'll be looking at square root functions and their graphs. So, and then that will be it for the whole semester. Yay! Oh, sorry. This says inverses and compositions of inverses. Sorry for the lousy handwriting. Excuse me. Yes. I don't know when those are going to get run. Probably in the probably before finals, those will be run. Okay. So we're going to find the inverse of some functions, and we're going to want to state their domain and range. So first off, we're going to find the inverse. We'll go with y equals x plus 1. Okay. So the domain and range R-A-N, there we go, of a linear function. So we're going to find the inverses, and we're going to find the domain and range of each. The domain and range of a linear function. Domain's going to be all real numbers. The range is all real numbers. If you think of the graph, looks like this. I can put any number in for x. So my domain is all real numbers. And my y's are going to infinity forever, positive infinity forever, and negative infinity forever. So my range is all real numbers. There's one technique that I use for finding domain and range. If I'm finding domain, I take every point and I squish it down to the x-axis, or squish every point up to the x-axis. Oh, well, I have covered the entire x-axis, so my domain is all real numbers. And for my range, I'll squish every point to the left to get to the y-axis, to the right to get to the y-axis. Oh, my whole y-axis is covered, so my range is all real numbers. It's a way to figure out domain and range, or you can just kind of memorize things about domain and range. I'm going to give you some, techniques for finding domain and range. So that's one. All right, so let's find the inverse of this function. The inverse is going to be x is equal to y plus 1. Subtract 1 from both sides, and I get my inverse is y equals x minus 1. I want my domain and range for these two. Well, one nice thing about inverses is because they are inverses and I'm switching the x and y's, I also get to switch the x and y's for the domain and range. So if the range was all real numbers in my original equation, the domain is all real numbers. If my domain was all real numbers in the original equation, the inverse has a range of all real numbers. Yeah, you just switch them. Switch the domain for the range. Yeah. All right. So, and it gets a little trickier if we get a little bit more complicated function, but that's for a basic one. All right, let's do the same thing for a square root. So we're going to find the inverse, and domain and range for y equals, maybe I'll make this f of x so that have practice with that. F of x equals the square root of x plus 1. Okay? My domain. Let's figure out my domain. We're talking about the real numbers this time and not the complex numbers. So for my domain, for square root functions, I don't want to take the square root of a negative number. So my x plus 1 there under the square root has got to be greater than or equal to 0. So that gives me a domain of x, subtract 1 from both sides, x is greater than or equal to negative 1. Now my range. So I might have to think of what this function looks like if I knew what it looks like. We're not even graphing them till tomorrow. But if I think of what this function looks like, there's what it looks like. It is always above the x-axis. Square roots always return positive numbers. So on a function like this, where all it is the square root of something, then my range, my y's, are always going to be greater than or equal to 0. So I can use that little squishy thing for my for my range if I want to. Let me see if I can do the squishy thing here. I'll squish in green. I take every point in my function and I squish it to the y-axis. So I take this point, squish it to the y-axis. I take this point, squish it to the y-axis, and the ones in between. This one, squish to the y-axis. Go to the right, and then take every point on this red graph and squish that to the y-axis. I got no points being squished below the x-axis. My range is all of these points, which are y's greater than or equal to 0. You like the squishy technique? You don't like the squishy technique? Then, yeah. It's shadow. You know what? If you're really well spatial, you know, you kind of like the squishy thing. And if spatial isn't your thing, then you probably don't like it. Yes, sir? I'll put a question. No. Oh, it was a question about that. Yes, Ashley. You're right. You got it. Okay. Now here we go. We're going to find the inverse. We'll do that in red. So my inverse is going to be x is equal to the square root of y plus 1. Solve for y. First thing I got to do is square both sides of this equation. So I got x squared is equal to y plus 1. Subtract 1 from both sides, so y is equal to x squared minus 1. Or I can write this as f inverse of x is equal to x squared minus 1. Now I need to get my domain and my range. And the range of my original function was y is greater than or equal to 0, so that becomes my domain. Greater than or equal to 0. But domains are always x's. So it's x greater than or equal to 0. Took this and I brought it to there. My domain of the original function was x greater than or equal to negative 1, so that's my range, greater than or equal to negative 1. But ranges are y's. So I say y greater than or equal to negative 1. So I've brought that here. Just exchange the range for the domain, but make sure you're making it in the proper variable. All real numbers, if I just say that, I don't have a variable named, but if I actually give some variables here for my range and domain, I need to switch them for my inverse.